In this lesson, we're going to learn how to compare fractions and decimals on the number line. In section 6.1, you already learned that integers can be negative. Fractions and decimals can also be negative. So let's say, for example, I asked you to graph 2/3 and its opposite. You're going to find that you do this the exact same way you do with the integers on a number line. What you need to remember, though, that when you're dealing with fractions, you still have to use equal intervals. So if I want to do 2/3 and its opposite, if I put 0 in the middle, my first hash mark is not going to be 1. I have to think about the unit fraction that I'm dealing with, which is 1/3, and write my intervals by that unit fraction. So my first one will be 1/3, my second one will be 2/3, and then the next one will be 3/3, which we would write as 1. And then it would be 1 and 1/3, 2 and 2/3. I'm sorry, 1 and 2/3, so on and so forth. When we do the negatives, then you have to do the exact same thing. You have to write it as negative 1/3, negative 2/3, negative 1, and then negative 1 and 1/3. Now if I'm graphing 2/3 and its opposite, I can graph 2/3, which is right here, 2/3 away from 0, and its opposite, negative 2/3, which is also 2/3 away from 0. Equal distance away from 0. The same thing happens when you're talking about decimals. So I want you to graph negative 3 and 5/10 and its opposite. When I'm thinking about what interval I want to go by to go into 3 and 5/10, I know that 5 goes into 35, so I could count by 0.5 or 5/10, which is really halves. Or I think, well, I also know that 5 times 7 is 35, so I could even go by 0.7 if I wanted to. So let's take a look at how that would look. If I go 0 here, and I have negative 0.7, negative 1.4, negative 2.1, negative 2.8, negative 3.5, negative 0.7, negative 1.4, negative 2.1, negative 2.8, negative 3.5. So it just gave me less hash marks or equal intervals to deal with. So then 0, this would be 0.7, 1.4, 2.1, 2.8, 3.5. Now you're not always going to find an interval that goes nicely into decimals. Sometimes you are going to have to graph in between the intervals. But if you could figure it out, it's a good idea to try and figure it out. So now I have graphed negative 3.5 and its opposite. Comparing is also done the same way, except when there are fractions, sometimes I think you're going to want to find a common denominator. So let's say, for example, I am comparing negative 1 and 2/3 and negative 1 and 5/6. So to me, what I might want to do is I might want to first change these to common denominators. Just because there's negatives, it doesn't make it any harder. I'm looking at 3 and 6 is my denominators. So I'm going to change this one to negative 1 and something. Negative 1 and something. If I have 3 and 6, my common denominator is 6 for both of them. This one RZ was 6, so I'm going to leave it. And then I'm going to multiply the 2/3 by 2 over 2 and make it negative 1 and 4/6. Now, when I make my number line to help me understand this, I'm realizing that I only need to have negative 1 to negative 2, because those are going to be in between there. This negative 2 might not work out very nicely where it is. And I know that I'm counting by sixths, so this is going to be negative 1 and 1/6, negative 1 and 2/6, negative 1 and 3/6, negative 1 and 4/6, negative 1 and 5/6, and then when I have negative 1 and 6/6, that's actually 2. So negative 1 and 1/6. So if I'm plotting them, negative 1 and 4/6 is here, and negative 1 and 5/6 is there. And I know that numbers further to the right on a number line are bigger, so I know that negative 1 and 4/6 is greater than negative 1 and 5/6. You're going to be able to do that with decimals as well. If I ask you to compare negative 0.51 and negative 0.4, I'm going to do what I always did with my decimals. I'm going to add zeros to make them the same. So I'm looking at really negative 0.51 or negative 51 hundredths and negative 40 hundredths. So I'm going to use my number line. I'm thinking about my tenths. I have a 5/10 and a 4/10, and I know that 4/10 negative wise is going to be closer to 0. So I'm going to put my negative and then I need to go all the way to negative 51 hundredths. So it doesn't always have to turn out exact. So I kind of want to show you one that doesn't. I'm going to count by 2's. So negative 42 hundredths, negative 44 hundredths, negative 46 hundredths, negative 48 hundredths, negative 50 hundredths, negative 52 hundredths. And when I'm plotting these two numbers then, I know that the 40 is here, and the 51 is exactly in between the 50 and the 52 hundredths. The 40, negative 40 hundredths, is further to the right, so I know that's bigger, which means the negative 51 hundredths is going to be less than negative 40 hundredths. Again, I don't think you're always going to need a number line to do these things. And you will only have to use a number line when the directions require you to do so. Okay, good luck on the lesson.